Hello class and welcome to lesson 5.9, which is review for our trigonometric functions test. All right, so first of all, I will tell you in this box here, ladies and gentlemen, this is the test that'll be, these will be the formulas that'll be provided on your test. So notice I give you two trig identities, just that one and this one. Just remember that for the second one, there are rearrangements of these. So for example, cos squared theta equals 1 minus sine squared theta. Okay. The other three, ladies and gentlemen, are your oblique triangles. So this is the sine law, ladies and gentlemen. And remember, you need to have a match in order to do this. And that's where you also look for the ambiguous case. And the other two, ladies and gentlemen, are your cosine law formulas. And this one is if you're given the side, angle, side, and need to find the other side. And this case is where you're given side, 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 and you need to find an angle. All right. So what do you need to know for the test? Because that information will be given, but what you need to know is your primary and secondary trig ratios. Just remember, folks, that your primary ratios are your SOHCAHTOA. Okay, and your secondary trig ratios, an example would be that cosecant theta equals the inverse or 1 over sine theta. Okay, so make sure you know those. Make sure you know which secondary trig ratio is the inverse of the primary one. Next thing you should also know is your special triangles. I would recommend you drawing these as soon as you get your test paper. So what do we know about a 1, 1, root 2 triangle? It's an isosceles triangle where both the interior angles are 45 degrees beside the 90 degree. We know that there's side measurements 1, 1, and root 2. Okay, taking a look at the second trig special triangle, it's a 1, 2, root 3. And I apologize, maybe that should be a little better like that. It doesn't look much like a triangle, does it now, gang? All right, so taking a look here, folks, we've got our 90 degree. I would say this is the 30 degree angle, and I always remember that root 3 is beside 30 degrees. This is 2, and this is 1, and this is my 60 degrees. Those are used for exact triangles, or for exact values. Use those two. Another special triangle which doesn't lend itself to the exact values, but we've seen this relationship in a couple of classes, a couple of examples. So ladies and gentlemen, if we have a 90 degree triangle and say we've got sides 3 or 4, we know the hypotenuse has to be 5. So the hypotenuse has to be 5, but 3 or 4 could be switched either way. It's just a shortened way of knowing a 3, 4, 5 triangle. It just saves you having to do Pythagorean theorem to find the third side. Okay, as long as the hypotenuse or the longest side is 5, then you can figure out the others. All right, ladies and gentlemen, what we need to remember is that we've got principal angles and reference angles, and they can be equivalent depending on which quadrant we're in. Okay, so if we're in, for example, quadrant 1, and say we've got a point P, which is x, y. In the past, we were taught to take the point and connect it to the origin. From the point, ladies and gentlemen, we know that the vertical movement is our y. We know that our horizontal movement is the x. And what we used to call hypotenuse, in this case, we call r being the radius, i.e. we could make that, turn that into a circle. Okay? And this is for, I apologize, folks, I'm jumping a gun a second, so let's back that up. I'm saving that for part D, so I apologize. I got too ahead of myself here. Okay, so what I wanted to actually put in here, we'll be revisiting that diagram down here in a second. What I wanted to put in here, guys, is the cast rule. So my fault, I got too excited here. So there's our cast rule. Just remember that our quadrants, Q1, Q2, Q3, and Q4. Okay, and the principal angle versus the reference angle. If I do an example here where I put beta being my reference angle, so beta in my diagram is going to be my reference angle, and my principal angle is going to be theta, which remember starts from the initial arm there and goes out, principal arm. Okay, Just remember that both the principal angle and the reference angle, if you're using any of your trig ratios, will lend itself to be equal or equivalent expressions. For example, okay, if I said that my primary or my reference angle equals 30 degrees, the sine of 30 degrees is going to equal, if we take a look at this diagram, the principal angle is going to be 180 subtract 30, which would be 150. So sine of 30 degrees is going to equal sine of 150 degrees. All right? Okay? And remember, folks, we have positive and negative angles. Positive angles go like the theta here drawn in the diagram from the initial arm going counterclockwise, whereas the negatives, if you're looking at a negative angle, it starts here and goes down. So that's going to be, for example, negative alpha going down, okay? The cast rule, remember, folks, it tells us when each ratio is positive, and controversially, it does tell you when things are negative. They don't appear there, they are negative. Remember, restrictions tell us the direction and the rotational limit, okay? And remember, if they're asking you for exact values, you're going to use your special triangles. All right, so again, I apologize for jumping ahead on that diagram. This is where I wanted to put that diagram, which is the point of a circle on a terminal arm. Okay, so say we have point, we're going to back it up like we did before, point XY. Okay, so as soon as we know point XY, that tells us some displacement. Take your point first and draw it to the origin. And remember, the point will tell us automatically our vertical displacement, which is y, and our horizontal displacement, which is x. That creates a 90-degree triangle. And what we used to call the hypotenuse, we now call r for radius, because you can imagine that being going on a circle. Okay? And the theta would be in the middle, so the angle that we'd be looking at is theta right here. Okay? All right, so just remember, folks, that in the quad 1, the reference angle equals the principal angle. If we were in another quadrant, say, for example, quadrant 2, our reference angle is here, and our principal angle is here, but just remember that the sine, for example, of theta equals the sine of beta. Okay? So they equal each other. So therefore, the sine theta of the principal angle equals the sine theta of the reference angle. Okay, and remember, your calculator is going to give you that reference angle answer, okay? All right, so quad 1, the reference angle equals the reference angle. In quad 2, remember, it's the complement of it. So you got to find the equivalent expression. All right, and based on using the circle formula, ladies and gentlemen, r squared equals a squared plus, r squared equals x squared plus y squared, we can now rewrite our primary trig ratios in a bit of a different form, okay, using the letters. The reason we use the letters and not opposite over adjacent is because in most cases we're given that point, which tells us what the y is, what the x is. And remember, to find r equals the square root of finding x squared plus y squared. All right. Next is trig identities, and we're going to do a recap of that right after this. So see next page for recap. Okay, so we're going to go over some homework questions to make sure trig identities have a little bit better understanding. And remember, you have sine law and cosine law. You use these when you have oblique triangles. Okay, so that means there's no 90-degree angles in oblique triangles. Remember that when you're using the sine law, you have a match. Okay, and cosine law, you have the two cases of side angle side, or side, side, side. And last class, or last lesson, we talked about the ambiguous case. So the sine law has two cases. So you could either have 0 answers, you could have 1 answer, or two possible answers. Okay, so here's your homework, folks. This is review for a couple days, so this would be 2 days of work, so don't think you have to plug it all at once. Okay, and again, we're going to recap the trigonometric identities on the next page. And if you need some help, please come and see me, especially with these trig identities, guys, because they are kind of tricky. So just remember, a quick recap, guys, for our trig identities is, one new one is tan theta equals sine theta over cos theta. And the second one is sine squared theta plus cos squared theta equals 1. And then don't forget your secondary trig ratios. Okay, so if ever you have a secondary trig ratio, you're going to eventually want to sub it in to the primary trig ratios. All right, so let's take a look at some homework questions, ladies and gentlemen. So on page 310, 3C, okay, looking at an expression like this, ladies and gentlemen, hopefully you notice that it's like a trinomial. And to make life easier, I'm just going to let x represent sine theta, or sine theta. So what am I left with? X squared minus 2x plus 1. I factor it through. I find my two factors. I notice it's a perfect square. So it's going to be x minus 1 squared. And then I look back and I substitute in that sine theta is what I substitute in for x. So I have to put it back in. All right, so that's just simplifying an expression. Okay, taking a look at 4b, we actually have an equation. Okay, so we've got a left side equals a right side. So remember to break it down into its left side and to its right side. Whenever I see tan theta, I'm going to sub it in right away. So in this case, I subbed in tan theta equals sine theta over cos theta. I left the denominator as it was. And remember, when you've got a fraction dividing by a fraction, you invert and multiply. Okay, and what do we notice here, folks? That we can, that we've got simplification here. So when we multiply through, we've got sine theta over cos squared theta. Cos squared theta, if you use your trig identity right here, if we rearrange it, ladies and gentlemen, isolate cos squared theta, we know that it's 1 minus sine squared theta, and we put it on the denominator, and what do we notice, folks? That the left side equals the right side. Again, there is many different ways to approach this. You could have rearranged the right side to get to the left side, as long as you use sound mathematics and approach and arrive at the same conclusion here, that left side equals right side. Then you're on the right track. Don't forget, ladies and gentlemen, to talk about your restrictions. Okay, so your restrictions is that cos theta cannot equal 0. Or what the textbook does is they actually go a little bit further and say, hey, what values of theta, when you sub it into cos theta, give you 0? So if you plug in your calculator, cos 90 degrees, that equals 0. Add another 180, and cos of 270 equals 0. So the other answer that I would accept, and again it's or, I'll accept either or, that theta cannot be equal to 90 degrees and theta cannot equal 270 degrees. All right, taking a look at 7b. Looking at the strategy, ladies and gentlemen, I notice it's already factored out, so I'm going to try to expand it and see if I can simplify. So again here, I'm going to use FOIL first, outside, inside, last. Okay. Then once I've got my middle expression here, I'm going to switch out secant theta to 1 over cos theta. The good news about this is I see where I can cancel right here. Okay, and when I cancel, I notice that I've got -1 plus 1. There is a cancel in itself. Okay, and so what I'm going to then do, ladies and gentlemen, is I'm going to multiply distributive law, multiply those through. And I know, so when I multiply, I have a cancellation here. So I have cos squared theta minus 1. Remember, that's related to our one of our trig identities. So rearranging that, it's negative sine squared theta. All right, and that is simplified there. Okay, looking at 7d, again, I'm taking a look at a whole bunch of cosecants. So I'm going to just let cosecant theta, I'm going to let x represent it, okay, to make it easier. Okay, so then I've got a trinomial to factor on the numerator and a difference of squares to factor on the denominator. Okay, when I find my factors, I notice I can cancel out here. And what I'm left with is x minus 2 over x plus 1. And that's your answer. Now the question came up here, hey Mazar, when do we know when to leave it as cosecant squared, or when do I change it back to my primary trig ratios? If it's an easy answer, folks, like cos theta minus 2 without a fraction, then by all means go ahead and do it. But since we've got an expression here divided by an expression here, it's going to be quite complicated to simplify it. It may not even look as good as this when you're done simplifying. Okay, so we're just going to leave it like that. All right, moving on here. 12a. Here's an equation. Okay, so we've got left side equaling the right side. And what I chose to do in the first one here is to replace that sine squared theta equals 1 minus cos squared theta in both the numerator and the denominator. Then I realized that I could cancel out because I've got 1 minus 1. Okay, then I did a factoring here. I common factored out a cos theta, and people preferred to do 2 minus cos theta instead of negative cos theta plus 2. It's fine, whichever order you want to have in. And then when we factor the denominator, you might want to do it on a separate sheet of paper. Our class chose to factor out a negative first to make it a simple trinomial, and then to get your solution. And what you notice is you cancel. So you're left with cos theta divided by cos theta minus 1. Okay, that's the left side. Now I got to deal with the right side. So with the right side, ladies and gentlemen, I noticed that, hey, on my numerator, I could common factor out a cos theta. And on my denominator, I can replace that with my other component of my trig ratio, the cos squared theta plus sine squared theta equals 1, just rearranging it. Okay. And then once I've done that, I realize that the denominator is a difference of squares. So I factored it through right here, ladies and gentlemen. And once I factor, you hope to do factoring so that you can eventually cancel to make life easier. And once you've canceled, you realize that, hey, left side equals right side. Therefore, the expression on the left equals expression on the right. And don't forget your restrictions here. So cos theta can't equal 0 or sine theta can't equal 0. All right. So there's a recap of the trig identities. They are probably the hardest thing in the course, ladies and gentlemen. So please see me if you need some extra help. Good luck with your review and happy studying. Have a great day.